This video is about graphing a square root function. To find the domain of a square root function, use the fact that the radicand, which is the expression under the square root, must be greater than or equal to 0. For example, if I had something like y equals the square root of x plus 2, in order to find the domain, I would go ahead and say x plus 2 has to be greater than or equal to 0. And so from there, if I subtract 2 from both sides, x would have to be greater than or equal to -2. So whatever expression is underneath the radical has to be greater than or equal to 0. To graph a square root function, start by finding the x value that will make the radicand 0. So whatever expression is underneath your square root, set it equal to 0, and that will be the starting point of your graph. Then you want to plot 3 more points on the graph and connect them with a curve. Try to pick x values that will create a perfect square underneath the radical, because then you'll get nice whole numbers to graph. So let's use this method and graph f of x equals 3 square root of x minus 2. So I want to go ahead and start by getting the starting point of my graph. The expression underneath the radical is just an x. And so for the starting point, I'm going to say x equals 0. And I have to figure out what the y value is based on my function. So my starting point is x equals 0. And if x equals 0, then y is going to equal 3 square root of 0 minus 2. 3 square root of 0 is the same as 3 times 0. So I get a -2. So my starting point is going to be the ordered pair 0, -2. Now I want to get 3 more points. And I'm going to pick values of x that will make a perfect square underneath the radical. So for example, x equals 1, x equals 4, because 4 is a perfect square, and x equals 9. Those would be good x values to pick, because when I plug them into this function, I'm going to get a square root of a perfect square. So for my second ordered pair, I'll have y equals 3 square root of 1 minus 2. Square root of 1 is just 1, so that's 3 times 1 minus 2. So I get the point 1, 1. That will be my second ordered pair. When x equals 4, I'll get y equals 3 square root of 4 minus 2. Square root of 4 is 2, so that's going to be 3 times 2 minus 2. 3 times 2 is 6 minus 2 gives me a 4. So I have the point 4, 4. And when x equals 9, I'll get y equals 3 square root of 9 minus 2. Square root of 9 is 3, so I'll get 3 times 3 minus 2. 3 times 3 is 9, minus 2 equals 7. So I have the point 9, 7. So now I just plot all of those points. I'll start with the 0, -2. Then I'll plot 1, 1. Then I'll plot 4, 4. and 9, 7 will be my last one. X is 9, Y is 7. And keep in mind, this 0, -2 was the starting point of my graph, meaning my curve is not going to go beyond that. So I'll go ahead and connect these with a smooth curve. And that will be the graph of f of x equals 3 square root of x minus 2. Let's look at another example where we have something more than just an x underneath the radical. Here we have f of x equals square root of x plus 4 and then plus 2 outside of the radical. So I want to follow the same steps. I want a starting point. And the starting point is always going to be where the expression under the radical equals 0. So here the expression under the radical is x plus 4. So I'm going to have x plus 4 equals 0. So my starting point will be when x equals -4. Subtract 4 from both sides to get the x equals -4. So then y is going to equal square root of -4 plus 4, and then plus 2 out here. So that will end up being 0 plus 2, which gives me y equals 2. So my starting point is going to be the ordered pair -4, 2. I know that'll be the edge of my graph. It won't go to the left of that point. Now I have to pick 3 more x values. So I want to pick x values that are going to make x plus 4 equal a perfect square. So think about what your perfect squares are. Your perfect squares are 1, 4, and 9. So I'm going to do x plus 4 equals 1, x plus 4 equals 4, and x plus 4 equals 9. That's going to make the expression under the radical a perfect square. So then I just have to figure out what these values would be for x. So this would be x plus 4 equals 1 would give me x equals -3. X plus 4 equals 4 would give me x equals 0. And x plus 4 equals 9 would give me x equals 5. And then I just have to find the corresponding y values for these. So when x is -3, I'll get y equals the square root of -3 plus 4. And then plus 2 is outside of the radical. That would give me a square root of 1 plus 2, which gives me a y value of 3. So this ordered pair is going to be x equals -3, y equals +3. All right, now let's look at x equals 0. I'll get y equals the square root of 0 plus 4, and then plus 2 outside of the radical. So that's a square root of 4, which will give me 2 plus 2 equals 4. So now my ordered pair is x equals 0, y equals 4. And for my third point, other than the starting point, I'm going to let x equal 5. So I get y equals the square root of 5 plus 4 plus 2. Square root of 9 is 3. So I get 3 plus 2 equals 5. So my last ordered pair will be 5, 5. Okay, starting point first, -4, 2. Then the next point is -3, 3. And then 0, 4. And 5, 5. Now, if I connect these correctly, I should get a nice smooth square root graph. Let's look at one more example using the ALEKS graphing tool so you can see what that would look like. I have it pulled up here. So graphing a square root function in ALEKS. Here's the function f of x equals square root of x plus 2 plus 5. And I'll use the same idea that I was using before. So my first ordered pair, I want to let the expression under the radical equal 0. So if I let x plus 2 equal 0, then x would have to be -2. If I plug a -2 in here, I would get a 5. You can use the calculator to do that if you need to. You can use the Desmos calculator and put in the square root, -2 plus 2, use the arrow to get out from under the root, and then add 5. So we have the point -2, 5. Now I want to pick values of x that would make x plus 2 a perfect square. So for example, if I let x equal -1, then -1 plus 2 underneath the radical would give me a radical 1. So I'll go ahead and let x equal -1. So I have the square root of -1 plus 2. Use the arrow to get out from under the square root and add 5. Now I want to pick the next one. I know my next perfect square is 4. So in order to make x plus 2 equal 4, x would have to be a positive 2. So I'll do the square root of 2 plus 2 and then add 5. And now the next perfect square after 4 is 9. X would have to be 7 in order to make x plus 2 equal 9. So I'll do square root of 7 plus 2, add 5. So there are my points. I have the point -2, 5, -1, 6, 2, 7, and 7, 8. So I just have to plot those. I have to remember those. So the first one was -2, 5. The second one was -2, 6. The next one was 2, 7. And then I had 7, 8. So now I just click the graph a function tool. It should connect those in a nice smooth square root function. And you're done. So remember, your order of operations for this is make the expression under the radical equal 0. That will give you your first x value to use. Figure out the y value that corresponds. Then for your other 3 points, select values of x that will make the expression under the radical a perfect square. So 1, 4, 9, 16, those are your perfect squares.